Okay guys, welcome to today's session. We are going to be talking about finding the equation of a perpendicular distance from a line. The equation of a perpendicular distance from a line. Okay, so what we are referring to is that supposing you have a line L1, right? And then there's a point here, okay, say P. Now we are finding for that perpendicular distance that is from the line. Sometimes it could go beyond the line depending on the context of the question, right? So it's not limited to the location of the line per se, but we are looking for that perpendicular distance, okay, from where P is. Now this perpendicular distance is 90 degrees to the line. All right, now we also know that every line has a normal vector. Every line has a normal vector. Now what is a normal vector? A normal vector is a vector that is perpendicular to a given line. A normal vector is a line that is perpendicular to a given line. So every line has a normal vector along it. Okay, now with this diagram we can say that we have a normal vector n over here, which is also perpendicular to L1. What does that tell us? What it tells us is that P is parallel to N. Okay, and if P is parallel to N, that means P is perpendicular to L1, and also N vector is also perpendicular to L1. Okay, so this is something that you want to keep in your head, okay, for future reference. Okay, so now let's get into it. So what is the formula for finding a perpendicular distance? So let's write down the formula. So a perpendicular distance which can be denoted by small d in reference to the point P. So dP could be written with the formula the distance along the normal over the length of the normal, right? So we can follow this up and write it in this equation form: ax plus by plus c all over the square root of a squared plus b squared, which these are the coordinates of the normal vector, right? So let's get into it. So if you have an equation, let's say equation of a line, let's say r equals a plus td, where a is the starting point, t is the parameter or the scalar, and d is the direction vector. Okay, so if you have an equation in this form, right, it's not going to help us in the form of the perpendicular distance. So we will need to convert it from this form into a form that has the x and y coordinates in it, which is also called the Cartesian form. So we are going to change it from the parameter form into the Cartesian form, all right, so that we can work out with it in the perpendicular distance formula. So now let's try and convert it from this particular form to the Cartesian form. So we are going to represent r by xy coordinates. So we have x, y is equal to, let's represent a by, let's say, r s. Then we have our t. We can represent the direction vector by u v. Okay, so now we are going to take the x coordinates and then the y coordinate separately to get simultaneous equation. So we have x equals r plus t u, which is equation 1. Then we have y equals s plus t v, which is equation 2. Okay, now you'll find out that we don't need our t, we don't need the t's. So because we don't need the t's, we are going to make t's the subject and then we equate the t's to each other. Alright, so we are going to have x minus r over u is equal to t. And then we also have y minus s over v is equal to t. So let's equate the t's to each other. So we are going to have x minus r over u is equal to y minus s over v. Alright, and we are looking to convert this. We are looking to convert this into the form ax plus by plus c. Alright, so we are going to make sure that everything comes to the left hand side because it should be equal to 0. So everything should come to the left hand side. But before that, we can cross multiply. So we have x minus r times v is equal to y minus s times u. Now let's expand further. So we have x v minus r v is equal to y u minus s u. So now let's bring it to the left hand side. So we are going to have x v minus r v minus y u plus s u, which is equal to 0. Okay, so now we can see our x here, we can see our y here. So let's bring them to each other. So we have x v minus y u minus r v plus s u is equal to 0. Okay, so we can see that this is looking like the form we want. Ax plus by plus c is equal to 0. So we have our x here, we have our y here. So we can arrange it well and say vx minus u y minus r v plus s u is equal to 0. So what that tells us is that v is our a, so a is equal to v, whilst u becomes our b, so negative u is equal to b. And we have all of this becoming our c, right? Then we have our x and y, which is representing x and y. Alright, so this is the form that we are looking for. So now we can insert this form into the formula of the perpendicular distance that we are looking for. Alright, so let's go ahead and work it out over here. So we know that the perpendicular distance d of p is equal to ax plus by plus c all over square root of a squared plus b squared. Right, so per what we had, we are going to have our ax plus by plus c as vx minus uy minus rv plus su all over the square root of v squared plus minus u squared. Okay, so this becomes the same thing as the formation or the formula for the perpendicular distance of a vector, and from here you can work it out. Now mind you, because we are looking for a distance or a length, we can equate it to the magnitudes. We can introduce the magnitude so that we get the absolute value, because a distance cannot be negative. We cannot have a negative distance. So we need a magnitude so that everything will become positive. Alright, so this is how to find the perpendicular distance from a point along a normal or to a line. Alright, so in the next video we are going to take an example and then we are going to work it out to get to this particular point. Okay, so see you in the next video. If you are new to this channel, kindly subscribe and hit the like button and stay tuned for more content. Okay, see you in the next video. Bye bye.